There are a number of plug-in modules available for the RadioLab, and these plug-in modules expand what the RadioLab can do. You can use them to build things like software-defined radios, audio amps, analog FM systems, or universal DSP receivers. They attach with RF cables or jumpers and are secured firmly in place. Essentially, each module adds a new capability, letting you experiment so you can design your own for your own experiments. And I'll go through the various modules that you can add to the RadioLab. So this is the SDR receiver module, and it converts incoming RF signals directly down to the audio baseband I&Q signals. The I&Q signals pass through a matched audio filter and a low noise op-amp stage to produce clean audio signals. These are then digitized using an I2S ADC and are fed into the ESP32 for real-time digital signal processing. The ADCs are 24-bit, which compared to many of the normal homebrew designs, which are 10 or 12 bits, and this gives a much greater dynamic range and prevents the receiver from overloading. So inside the ESP32, we've digital filtering, demodulation, Hilbert transform. All of these are implemented for proper CW and SSB reception. We have a dual channel DAC is also provided and a pot to balance the I&Q signals. This allows excellent opposite sideband suppression and lets you experiment with phasing and image rejection techniques. The module allows you to experiment from long wave up to 30 MHz. Full design details are provided, and you can modify the filters, experiment with your own DSP algorithms, and truly understand how software-defined radio works from the ground up.
You've said there is correct, and there's so many flaws that you can put.
This is the universal AM, FM, shortwave and longwave receiver module based on the IC SI4735. It uses that integrated digital receiver to provide complete wideband broadcast and HF receiver in a single module. It supports AM, FM, shortwave, longwave reception. It has a built-in DSP and AGC for noise reduction, automatic frequency control, completely controlled with I2C and full software configuration here. We can decode both SSB and CW, and it's a perfect module for if you want to make a fast functional receiver, if you want to do some performance benchmarking and comparison against your own analog or SDR designs. In this case, I've set up as an FM receiver.
Gomez got injured as well off the back.
Your nerd hat on.
They could come up again.
We were good on Christ.
I say perfect for doing very fast functional receivers. And now we have the analog FM broadcast module. And this module is important because FM circuits using modern analog components, especially for the 2-meter band, are very rare. Most hams rely on older ICs or don't build them at all. So this module really fills that gap. The signal enters via the antenna, goes through a bandpass filter, then into the wideband RF amplifier, over to the double balanced mixer where it's mixed down to 10.7 MHz. Then it goes across to a 10.7 MHz filter, and from the filter it goes to the intermediate frequency amplifier, and then finally over to the demodulator, where it extracts the audio and feeds that to the audio amplifier.
You can buy gold to nil at Chelsea.
It's a really practical circuit for learning analog FM design and can be used as a starting point for your own designs for both broadcast and 2-meter FM design. I have now added the Class AB audio module, and this is a fantastic learning tool for transistor circuits. We start with a volume control, and then we go to a Class A audio amplifier, followed by a driver and a push-pull output stage. And you can experiment with different biases using jumpers, Class B, diode bias or VBE bias. And there's also a transistor-based current limiting circuit to protect the rest of the circuit. So beginners can replicate each section on the breadboard, tweak components, change biasing, make the design their own. And in the end, you gain hands-on experience and confidence with transistor audio amplifiers. Plus, it's actually really useful. There's enough volume comes out of this amplifier to fill a room.
Turned around, curled a lovely one into the bottom right corner of the net, and Arsenal are looking really fine as they boost up their goal difference.
This is the RF amplifier board that turns the RadioLab into a transceiver. The antenna input passes straight through to the receiver's RF filter in receive mode, so the receiver works as normal. In transmit mode, the board takes an RF input, such as from an oscillator, amplifies it to about 5 watts, and then passes it through a low-pass filter, in this case a 40-meter one, and then routes it either to a dummy load or to the antenna. And this dummy load is under the board. You can see what it looks like at the back. And it can be used, obviously, in conjunction with this board, but it can also be used as standalone dummy load for other amplifiers that you're building just by changing some jumpers. A key feature, I just put this onto the dummy load, a key feature is how we handle the side tone in this setup. Instead of what's normally done, generating a tone from an audio oscillator when the key is down and then stopping it when the key is up, when we transmit, this mixer is turned into a direct conversion receiver. It picks up the RF from the amplifier, mixes it down, producing an audio tone. This real RF side tone is fed into the audio amplifier, meaning that you're monitoring the actual transmission. And this makes it a really powerful solution, especially when experimenting with amplifiers. You're listening to the actual output. And if we move this around, you'll hear the signal will change. So this system, as well as, it supports full break-in, also known as QSK. So as soon as you key down, it switches from receive to transmit. So you can hear the click back between receive and transmit there. You can also press a key here and it will send out a full CQ for you. And we can continue to do that with a gap, and then you can stop that at any stage if you get a reply. And you can also, for testing purposes, instead of using the Morse key, you can use one of the switches on the RadioLab itself. And this module will work with any receiver that you build. It'll also work with all the RadioLab receivers like the super heterodyne, the direct conversion, the SDR, and the universal receiver. There's also an extra area here for you to put in a custom filter for any band that you want to experiment with. And this module will allow you to communicate across the world.